So, welcome back on LightWave Guru. And Julian E. Herring had a question. Did you add the snow on the trees yourself? So I think somebody have seen that snow scene, and it would be later published on LightWave Digital on that YouTube channel from LightWave Digital. And my answer was, that's library stuff, Julian. So you can buy that trees for summer and winter and so. That's complete sets. So that you have it if you want, but you can do it for yourself if you want it, and if you have enough time, you can do it. So in what way you can do it? You can do it in the following way. You use the vertices from your tree as solver or emitter. Let us call it emitter. That's better to understand. To create in combination with OpenVDB that snow. Yeah. So, and for that the first step is to load in the tree and then say the particle FX system that he put out on the vertices from the tree, for example, for every vertex a particle. Yeah. And I have now here that snow PFX, and the reason is it needs a while to do that. Yeah. And the thing is this, and my example here is I have 900,000 particles for that example. Yeah. And that's generated by frame, and the nozzle is object vertices. Yeah. So it needs a while to build that up. But if you have it, then you can save it as snow PFX, and then you can work with that snow PFX. That make it much more easier to work than with OpenVDB. Yes. So the basic is you load in a tree with enough vertices, and the reason you need enough vertices is you have to define for OpenVDB a particle size. Yeah, so that OpenVDB knows in what dimension the particle works. You can see it with output size before you fix it as a PFX file and save it. And in my case, the particle size is 0.02. Yeah, so the particle have now a volume. Yeah, and all that volumes you see here, that little particles have now the chance to do that what the old metabolts do if he comes in contact or near or sit nearby to another. Then you can play with the OpenVDB filter, Gaussian for example, or other filters to do that what metabolts do. Yeah, so that means the following. It's really simple. You see now, I have here that tree with that 900,000 particles. It's saved in that snow PFX. If you load the scene, so I save then the scene, then you can play for yourself with that. I put it under the video so that everybody can download the scene and play with it. You do the following. You create simple null object. In my case, all my null objects, if I work with OpenVDB, it's called evaluator. Yeah? And that evaluator, that null object, you give that object replacement OpenVDB evaluator. In LightWave 2024, is it a little bit different as in 2019. So there you have here that button, that's P. And if you press that button, you become that here. Yeah. And it opens this here. So, and as first you go to OpenVDB and load a simple solver, this solver, and say that solver, okay, use a particle system from LightWave for that, and my particle system is 346. So that's my, yeah. And at the moment my voxel size is 0.03. Yeah, you see it. And if I now put it in so that you show it in OpenGL preview, you would see what that mean. So I do here the following. I put it now in here, and I have here a filter, by the way. Yeah, and put it in the grid. And now it needs a moment, and OpenVDB will now create the mesh for all the particle. So my GPU go up to 100% and builds that mesh. So, and now you see it here. I make that mesh red so that anybody can better see it. Yeah, as in white, so you can better see it. And with that, you can now play your snow games. Yeah. So in the moment, I have a voxel size from 0.03 in OpenVDB, so that OpenVDB understand, okay, I have to generate that, what I do with that size. And now you can, with that filter, play a little bit. And now let us play with the filter a little bit. Wait a sec. Make it more here, so that we see it better. And my filter is in the moment the Laplacian flow. So if I, for example, do here nothing, yeah, so the default is, I think, erode. Yeah. Let us see what's happened now. So that's, yeah, for example, erode. So you have no filter in there. So you build for every particle now here a little geometry and box. But that's not what we want to have. Yeah. So there are other filters. So for example, let us test median value. Yeah. So that we have a closed snow parts on the tree, yeah, or a second layer, call it so, and then you that see here, yeah, this here, and in that way you can build your own snow layer. So in the end, if you mean you love it and you need it, or you would build then, or work with that layer in modeler, to bring that OpenVDB geometry in a tree as a layer, yeah. Then you do the following. If all that's happened, you can save it then as save transform object, yeah. And you can then call it, for example, here snow1, and save it. Okay, and that's all. And if you have that, you can then load that object you built with OpenVDB and use it to work with that. For example, you have here that snow1 I built here. So that's what's the output, yeah. And then you have your tree here. No, let us make it quick and dirty. Yeah, you have now your tree here. So now that's here the leaves, that's in the winter not the case, but you have here your tree, yeah? And now you can take your transformed object and put it in the layer here, in the third layer, and you see now where here is snow. Sorry. So, and now you can edit here what you want from them and what not, yeah? And that's later. You can also copy it then in the same layer as the tree himself. Yeah, that's not the problem. You have then only a surface more. Let's call it snow. Or you let it as extra layer. That's what you want. So now you can here edit, for example, on that OpenVDB if you parts not know. Yeah. So if you say, for example, okay, this part here is not what I want, then you select it with select connect. And then delete it. Yeah, so that's the way to build your own snow layer. And yeah, it's really simple. Okay, so it's nothing secret on that to build things like that. Yeah, so you see it. So one more time, load the tree with enough vertices. Build on that vertices the particles. Yeah, and that particles save in the, as a snow PFX or something like that. Yeah, so that the LightWave particle system have nothing to do, so I have only to load that file. Then open, build the evaluator, a null object, open there, the open VDB displacement function, load a solver, put in the solver the particle system, here, so your tree, and then, yeah, put here in a filter and play with the filter, and what you see is what you get. Yeah. So Julian, I hope it helped you a little bit. So that's the way if you want to build for yourself the snow. Yeah. So there, this way to do it is, I think for myself, if I've seen the library files with the snow, yeah, my snow trees, I have seen it's the same way. He built it also with OpenVDB, trust me. So, and for example, if you want not to build snow for the complete tree, yeah, then copy out the geometry on that you would create snow. For example, you copy then out some from that parts here, yeah, and play only that play only the game with that parts. So you must not load in the complete tree. Yeah, it's enough to load in, for example, all parts you need to see snow later. But that's in principle a way to do that. Another way is to do it with Flow. Yeah, there you can also do that. But OpenVDB is here very efficient. Yeah, you can see it. It works in real time, and you can see all, and so on and so on. So, and now we have winter. Have fun to create snow on trees. Yeah, later. Bye.